Hello, everybody. Welcome back. Today we are going to be talking about monitoring your monitoring, also called monitoring your meta logging, which is basically logging what your monitoring is doing, right? Logging your monitoring. Understand the concept, what we'll be learning, right? You'll be learning by the end of this module. You'll be able to understand the concept and importance of meta logging, implement monitoring systems for security monitoring infrastructure, design health checks and alerting for monitoring systems, establish metrics and key performance indicators for monitoring effectiveness, troubleshooting monitoring system failures and blind spots, implement redundancy and failover for critical monitoring components. Meta logging, also known as monitoring your monitoring, refers to the process of or practice of implementing oversight and health monitoring for your security monitoring infrastructure. It's a why is it monitoring your monitoring critical? Blind spot prevention, system reliability, compliance requirements, incident response with critical events, right? So why do we do it? Why do we make sure our monitoring is monitored, right? Because we need to know the health of what our monitoring, the infrastructure of it, right? If that monitoring goes down, you're not going to be getting any of those logs, right? So it's important that you have another monitoring tool on top of your already existing one that manages all your infrastructure. So it can monitor system health and stuff like that of the other monitor, right? The one that's monitoring all the logs and all of the infrastructure. You also have all these, right? You might have a compliance requirement they have to meet, but you also have monitoring infrastructure health, system performance and availability, which will be very important if you're like on a high availability system, right? Data flow integrity, ensuring logs reach their destinations. Alerting system reliability, verifying alerting mechanisms function properly. Coverage validation, confirming all required resources are monitored. Components of meta logging. Infrastructure monitoring, of course. It'd be monitoring CPU, memory, disk, and network utilization, meaning what is allocated to what, how much seen it before. But in Proxmox we had where we could see the CPU usage and the percentage that's being used. And this health metric is showing how much CPU is being used and stuff like that. Is it 100% or what is it, you know? Or is it only being used 50% of the CPU? You also have application level monitoring, which is basically log ingestion rates, because an application is going to have logs, right? Query performance and response times, correlation engine performance, user, session, and authentication metrics. You're also going to have data flow monitoring, which is individual log status, source status, and connectivity, log volume, trends and anomalies, parsing success and failure rates, time delays in the log delivery, pipeline integrity, data loss detection and quantification, processing bottlenecks and queue. Okay, so we have storage, basically pipeline integrity, data loss detection and quantification, processing bottlenecks and queue depths, transformation accuracy and completeness, storage and archival success rates. Alert, for that, the integrity of the pipelines, meaning that they don't get changed and stuff like that. You don't get data loss, meaning someone exfiltrated data, right? But for like alert system, you got email, SMS, and other notification channel health, right? They got delivery confirmation and acknowledgement tracking, escalation procedure effectiveness, alert fatigue, and suppression metrics. Meaning like whenever you get the email, you can confirm, and that verifies that you actually received the email, right? They have alert quality metrics, false positive and false negative rates, mean time to detection, mean time to response, alert correlation, and deduplication effectiveness. And I mean, what the other mean time, you got mean time to repair, mean time to repair, and mean time to I don't know the other one, but they have like a couple of them. I'll write them up here on the screen. But we have implementing monitoring system health checks, automated health checks, SIEM service availability, database connectivity, web interface response, API endpoint availability. license, utilization, and expiration. So we got performance thresholds, meaning the latency and all those different like resource utilization things. We have data integrity with log volume monitoring, which basically log volume monitoring, you're logging those detection and handling, right? Missing or delayed log batches, significant deviation from baseline patterns, expected versus actual log volume per sources, meaning it'll log all of that stuff and show you if you have a missing or delayed log package, stuff like that. Parsing, we got percentage of successfully parsed logs, unknown or unparsed log format identification, failed extraction accuracy, validation, normalization, quality assessment. We have synthetic monitoring. Test event injection, generate known test events across the monitoring pipeline. Validate end-to-end detection and alerting. Measure detection time and accuracy. Test and alert notification delivery. Deploy monitoring canaries to test system responsiveness. Use synthetic transactions to validate system functionality. Implement heartbeat mechanisms for critical components. Test failover and recovery procedures. For KPIs for monitoring systems, we have system uptime, data availability. So that's the two most important metrics, right? And availability. Then we have performance metrics, which is efficiency, resource utilization. For quality metrics, we have detection effectiveness. So how able are what's the success rate and false positive rate of, say, malware going on your system? How is it able to detect it, and is it able to make sure it's like a true positive or a false positive? Is it getting wrong? Is it saying, oh, this is just a false positive when it's actually is something that you need to be worried about? They also have operational metrics for alert acknowledgement times, incident escalation rates, user satisfaction scores, training and skill development metrics. You have critical alert categories, system failures, data loss scenarios, performance degradation. For alert prioritization framework, you have critical alerts, major alerts, minor alerts, and informational alerts. Escalation procedures, immediate notification for critical issues, time-based escalation for unacknowledged alerts, on-call rotation and backup procedures, execute. So we also have alert management best practices, which is noise reduction, which is basically, from my perspective, what it is noise in the logs. So too much jargon in it, right? That's not getting you to the main cause of the alert. Stuff like that. And like having to search through way too much stuff to be able to figure out where that log is. That's why it's important to like classify what logs you're going to be doing, because there might be like critical ones that are part of like authentication attempts, stuff like that. But if you just get like a bunch of noise, that isn't good, because you have all of that jargon that you're going to have to search through to be able to find the right one. We have documentation requirements, which last video I said, yeah, you really need to key in on your documentation skills, right? I said in the last video, like the most important thing, if I didn't teach you anything else in that video, was that you need to know how to document stuff and to document everything, right? But yeah, this is just some of the stuff, right? Escalation contact, who you'd contact if you needed to escalate something, right? Redundancy and failover strategies. We have high availability design, multiple seam nodes with load balancing. And I mean, from component redundancy, I just think from a scaling load balancing standpoint, whenever I hear component redundancy, because one of those components could fail, right? But then you have this other cluster, or whatever you want to call it, take over. And you have database clustering, right? That can replicate and make more clusters if it needs it, which is actually pretty cool, right? We have redundant network paths and connectivity, backup power, stuff like that. Because say all of your power goes out, boom, now you don't have any servers up and running, right? So like what would be classified as backup power? I mean, uninterruptible power supplies, of course, right? Like battery backups, just stuff like that would take over in case of a UPS is a battery backup, right? But it plugs into the wall to charge, and then it plugs into like your surge protector or something, which is just a UPS. Then we have multi-site deployment strategies, data replication across disaster recovery. This is stuff you should have learned in Security Plus, right? If you ever studied for the Security Plus, and if you didn't, that's okay. I mean, you still pass. You will still pass CySA if you haven't really taken Security Plus. It just Security Plus gives you those. It gives you knowledge of all like the basics and stuff across the whole broad range of stuff. So the CySA is more like niched down in the blue team stuff, where you're actually going to be doing blue teaming stuff. And I hope in a couple videos we can do a lab, right? Because I still have like 24 videos that I got to do, right? But for failover mechanisms, we have the automated failover. It's automatically going to move to that other system. And it's going to be like data synchronization, service restart and recovery, automatic traffic redirection, health check based failover triggers. We also have manual procedures, failover documentation, validation procedures, recovery plans, rollback, communication and notification protocols. We also have data backup and strategies, right? Recovery testing for disaster recovery, point in time recovery. And we have full system rebuild procedures, recovery time objective validation. We also have coverage gap analysis, log source inventory, right? Where is the source of your inventory logs? Where are you pulling logs from? Network visibility assessment you have. 7.2 detection role effectiveness. MITRE attack framework, attack techniques, role performance and accuracy, gap identification and remediation. You know, just red team exercise monitoring. I mean, you still have to know red team, even if you're going on the blue team side, because it makes you a better candidate for any job if you have both red team and blue team, because you know both sides. You know how a red team attacker might think, right? So you need to know penetration testing regardless, threat hunting effectiveness validation, purple team collaborative assessments. We also have temporal blind spots, which is like 24/7 monitoring capability validation. I mean, you're trying to get rid of all these blind spots that will not, I mean, though, basically, if you don't get all this stuff set up right, there'll be a lot of like weak points and blind spots that you have that people don't think about, but later it won't be good, right? We have historical analysis, right? So, I mean, that long-term data, that cold data I was talking to you about in the last video, right? That would be the long-term data retention valid, and you want to validate that data as well. Make sure it hasn't changed from that time, but they might be adding stuff to it, so it is going to change a little bit. For monitoring system architecture documentation, we have component mapping, right? When I think component, I think graphics card, CPU, right? RAM, stuff like that when I think about components. But components can actually be those backups, those backup power stuff and stuff like that as well. Or it could just be the networking equipment. You could have routers, you could have switches, stuff like that. They have to connect in these sophisticated architecture diagrams that illustrate the data flow and processing documentation. And I can't say how much documentation on this means to the person actually setting it up. Because if you just give them a map of how to, just the map, how are they going to know how to set it up, right? They don't know, like, certain things. So if you're an architect, you have to know some of how to build that stuff too. So it's important that you know how to build the stuff, even if you are an architect, building out these plans and stuff. But we also have configuration management, baseline configuration documentation, change control and versioning procedures. And I mean, this is just like, and I see people use like dot files to manage their Linux configuration and backing it up to GitHub, right? Dot files are basically, you use these redundant symbolic links that link it to it regardless, and then the GitHub goes and shows you all your dot files, right? Dot files are really cool. Then we have the backup procedures, right? Configuration backup and recovery, security hardening documentation. And there's cases where you don't just want to put your config on GitHub. If you're like an enterprise company, you don't want your competitors getting that config, right? Because they could use it to their benefit or use it to attack and know how your configurations are set up. and know these different vulnerabilities that could happen to your system. So don't go think, I'll just put all these configuration files on as dot files on GitHub, right? Because people can get into that. You also have security hardening, which applies to a lot of different things. It applies to routers, switches, PCs, smartphones, like iPhone, Apple, Android, Linux, stuff like that. But when you're thinking about that, you also got to be thinking about hardening your Docker containers, hardening your Kubernetes stuff, and it doesn't just apply to like containers and stuff. It applies to VM hardening and stuff like that. Because there has been instances where VirtualBox, they actually figured out like a vulnerability on it that allowed it to use what VirtualBox's code and make it so that they could VM escape, right? Escape the VM, right? From effectively using like a vulnerability that was found in VirtualBox's code so that they could escape that VM. Say there's like a piece of malware on it that allowed it to VM escape. Say you downloaded a piece of malware on your VM and it had the power to be able to escape through the vulnerability of that code, right? So really nothing's safe. Even these VMs that we're using aren't safe, right? We have standard operating procedures. You think about business operations. Think about that when you're seeing standard operating procedure. And I mean, it could be really anything, any procedure, it could even be a technical procedure, right? Think about incident response and escalation, monitoring, right? Routine maintenance and performance. Routine maintenance, right, is basically making sure all of your like components are like being like cared for and stuff like that. Because you have like hard drives that like they die because they're only allowed to write so much data. But I mean, it's an extensive amount, but they're really only allowed to write so much data till they fail. So keeping a routine maintenance on it, cleaning your servers out and stuff like that, and making sure you have fire suppression systems, stuff like that, so whenever your servers catch on fire and stuff like that. But that's standard operating procedures, right? You also have troubleshooting guides, common issue identification and resolution, performance problem diagnosis procedures, log source connectivity troubleshooting. These are like guides. People have troubleshooting guides, right? Of how to fix things that break. And of course, those guides aren't always going to work because they might be outdated and stuff like that. But you got real-time dashboards, stuff like that, availability, uptime reporting, and just stuff so that you can be compliant, right? Regular reporting. And I mean, there might be a third party that actually makes sure and audit you, third-party auditing, right? You have reporting, weekly reports, monthly reports, quarterly, and annual disaster recovery and testing reports. So, I mean, regular reporting is very, very important as well. But I say reporting is like the next step up in importance from documentation, but documentation is the most important thing. For cloud and hybrid environment considerations, we have cloud service integration. I mean, I see cloud native monitoring. I see like hybrid environments, which is like you have some on-premises servers, stuff like that, and just how you integrate that stuff together. Because I don't know how secure it would be to actually go and put like a hybrid environment, connecting cloud to your servers. I don't know how secure that would be, because if someone got into your cloud, right, and knew all the passwords and stuff, boom, they have access to all your on-premises stuff, right? That's why it's important to never use like root, stuff like that, because root gives all the permissions and stuff, right? Especially in Linux. You have microservices, which is like health, service mesh monitoring integration, Kubernetes cluster monitoring, serverless function monitoring. And when I think of all of that, I'm like, we are actually monitoring all these like monitoring tools, which adds another layer of complexity, but we need that other layer of complexity so that we are able to, make sure that those services that we need to be available don't go down. And if they do, we have that extra monitoring that will alert us if something goes down, and we'll have a faster response time to go fix it, right? We have compliance and data sovereignty, which is basically, I think GDPR when I think data sovereignty, because they are so strict. GDPR is so strict about EU data, right? Personal info. And US, they really don't care. And the United States, they can collect any information they want about you, right? if you give them, like Google will collect anything about you, right? Automated remediation, we also have like health systems. What they do is they like have these procedures in place that make adjustments and stuff like that. This is when I think automation, self-healing systems would be automated, right? But of course you'd have to have safeguards in place in case those automations, safeguards is like being able to revert back, having a rollback plan, stuff like that. Because if your automation goes and changes a bunch of things and you don't know what changed, you might just want to revert back. And I think version control, whenever I think that, because version control saves literally every version of your stuff so that you can go back to any version, right? And that's mainly for code. I mean, it could tie into automation, stuff like that, but that's like different stuff. That's what you're talking about, a whole nother thing, right? But workflow automation, I mean, they're automating incident response. They're automating task scheduling, report generation, alert acknowledgement. They're literally automating anything a human would do, right? With DevOps, I mean, they got infrastructure as code, which is really, really important because it's basically code that is integrated into different applications, stuff like that. And like I said, version control, Git is version control, right? And it just saves all your like code and stuff. And I mean, you'd be using infrastructure as code to deploy this automation. You have Ansible, you have like, I think Terraform. Whenever I think infrastructure as code, I'm thinking Terraform, right? What is Terraform? Terraform's like some sort of automation thing, I thought. But Terraform definitely relates to infrastructure as code. And then we will be talking about Terraform in this course. I mean, why not? We have CI/CD pipelines, right? Now you have continuous integration, continuous deployment. I've been telling you about CI/CD pipelines, and we also have automated testing of monitoring configurations. And I mean, it literally can deploy all this code, right? But an important thing in like CI/CD pipelines, version control. Version control, because like you're integrating, you're deploying stuff. What if you need to revert back, right? DevOps isn't really like a job. It's more of a mindset or a business model, you know what I'm saying? But they do have like DevOps engineer jobs, stuff like that, which would engineer these different models, business models, and CI/CD pipelines. Of course, they got to know a lot more about than just CI/CD pipelines and infrastructure as code. They got to know from an engineering standpoint how to best help a business, right, achieve their goals and stuff. But I mean, here's like the practical implementation. We don't have to go over all these, but if you do want me to go over them, I'll go over them right now. But I guess I'll go over them because, I mean, this could be pretty valuable. We have system information event management, system, experience gradual performance degradation without obvious cause. So, I mean, if it's experiencing that gradual performance degradation, we'd want to monitor that, because why do you think we would want to monitor that? Because that is actually gradual degradation performance. So I mean, your CPU could be degrading, stuff like that, and you want to track that with meta logging, meta-logging is basically monitoring with logging and stuff like that. So baseline performance monitoring approach: query response times and process delays, monitor resource utilization trends, establish automated alerting for performance thresholds. Solution would be deploy synthetic transactions, create performance for real-time monitoring, implement capacity planning and based on utilization trends, establish proactive maintenance procedures. You see, in this second scenario, we have intermittent log source disconnections causing data gaps. Intermittent log source, so it's disconnecting, causing some of the logs not to be able to transfer, right? Implement heartbeat monitoring for all log sources. Track log volume baselines and deviations. Monitor network connectivity and performance. Establish automated reconnection procedures. Deploy connection status monitoring with immediate alerting. Implement redundant log collection paths where possible. Create automated diagnostics and recovery procedures. Establish manual escalation for persistent issues. So I mean, for this scenario, just implement that heartbeat monitoring for all log sources. Track the volume of logs, meaning how many logs are coming in and out, right? Versus what your baseline is. And monitor network connectivity, the performance of the input and output of it. and latency and bandwidth, stuff like that. Also, establish an automated reconnection procedure. That is all stuff that would help make that gap like almost non-existent. Almost. You're not going to completely remove it unless you figure out what the root cause of those disconnections are. If you figured out what the root cause of those disconnections, there is a chance that you could 100% fix that problem, right? That's why it's important to implement these steps first and figure if it's gonna fix it or not. But we also have alert fatigue and false positives, meaning you're getting so many false positives that you're getting a high volume of false positives. And reducing analyst effectiveness, meaning the analysts can't do their job because they're getting this influx of false positive alerts. Alerts that aren't even a real threat. That's what a false positive is. It's not even a real threat. A true positive is actually a threat. That'd be like you got malware on your system or something. But a false positive definitely is, A false positive is not really a threat, right? Implement alert quality metrics and reporting. Establish regular alert rule review. So this is how you improve your process and you create feedback loops for continuous improvement, which basically, feedback loop, feedback from the customer or feedback from your team, I don't know. But you're always expecting that continuous improvement, right? Compliance and audit considerations, we have monitoring system auditing, user access and activity logging, configuration change tracking, system maintenance and update logging, performance and availability documentation. You also have compliance reporting with risk assessment, mitigation tracking, control effectiveness, stuff like that. Audit finding, tracking, and remediation. Regular compliance status reports, stuff like that. For HIPAA, for healthcare, PCI-DS for payment card industry. SOX is for financial reporting system to detect fraud, I think. PCI-DSS is also for fraud. GDPR is data processing and monitoring. So we have documentation standards, which is a baseline for your standards, right? And basically saying your documentation has to be up to this code, stuff like that. That's why auditors and stuff look at it and stuff like that. Making sure that you're up to date on everything, right? So we got AI and machine learning, right? Emerging technologies and trends. AI enhanced monitoring, automated anomaly detection, right? For monitoring systems, predictive failure analysis and prevention, intelligent alert correlation and prioritization, automated remediation and optimization, machine learning applications. So AI can predict failure and predict what's going to happen in the future, right? Stuff like that. It can't predict everything, right? As of now, it can't predict everything, right? But it can get a good idea if something's going to happen or not, just based on certain factors and stuff like that you give it. They also have remediation, automated remediation. What is remediation? Remediation is basically, boom, you just got attacked by malware. So the AI is going to go fix that, right? They have that, right? Do they? They have AI that can go, oh, you got malware on your system, boom, take that off. I'm not sure they have that yet, but very possible that in the future they'll definitely have that. They have machine learning application, behavioral analysis of monitoring system performance, predictive capacity planning and scaling, automated rule tuning and optimization, threat detection effectiveness and improvement. That's what machine learning can do, right? Analysis on different things, predictive capacity planning and scaling. And the crazy thing is, AI could probably do machine learning as well. So you can build out machine learning applications with AI, right? You also have zero trust. So this is like the principles of it, making sure everything that zero trust stands for is being implemented. Implementation considerations. You might want an IAM, which is identity and access management for monitoring systems, network segmentation and monitoring, data encryption and key management. You might have a HSM or a TPM, stuff like that. What is an HSM? It's a hardware security module that stores your encryption keys. A TPM also stores your they store your public keys. They expect you to have like a private key on it, right? But they also have system on a chip, stuff like that on Apple that helps a lot because they got a whole nother computer on this chip, right? That's what a system on a chip is. It's just a whole nother computer. And Apple uses that for verification, zero trust stuff, all different types of things, managing your passwords and stuff like that. Best practices, design principles, implement monitoring from ground up, not as afterthought, Establish clear metrics and key performance indicators for monitoring effectiveness. A key performance indicator is like stuff that's happening, like CPU goes up to 100, stuff like that. It might alert you, stuff like that. Maintain separation between primary monitoring and meta monitoring systems. So they're saying segment or put a firewall on your meta monitoring systems so nobody can attack it, stuff like that. I think that's what they're trying to say for that one, because they could separate that with the firewall or an IPS, stuff like that. Because a meta monitoring system is just another PC out there that has that monitoring software on it that is monitoring what those other things are monitoring, right? Which I've never thought about this, but now that it's coming to the light, monitoring, basically meta monitoring systems, I never thought that you'd be monitoring your monitoring systems. But now that I know that, it's become very clear to me why you'd want to do it. Because, I mean, for compliance, definitely. If you have to be in compliance with certain things, they probably would definitely want you to use meta monitoring. Establish regular review cycles for monitoring system health. Implement graduated alert to prevent alert fatigue. Maintain skilled staff and provide ongoing training. Regular disaster recovery and failover testing. Continuous improvement based on lessons learned. So single points of failure, inadequate documentation. That's why I said documentation is really important across all of security, right? Any industry needs documentation. Over-reliance on vendor support without internal expertise. Insufficient testing of backup and recovery procedures. Neglecting to monitor the monitoring system itself. Key topics: understand meta-logging concepts and importance. Implementing health checks and monitoring for security systems. Designing redundancy and failover mechanisms for monitoring infrastructure. Establishing KPIs, key performance indicators and metrics for monitoring effectiveness. Identifying and mitigating blind spots in monitoring coverage. So, I mean, this is going to be some of the exam scenarios. Study tips and conclusion. Success in this area requires a combination of technical expertise, operational discipline, and strategic thinking about role of monitoring and overall security operation. So, thank you everybody for watching. In the next video, we will be talking more about log ingestion. And I promise you in like 2 or 3 videos, we'll be getting into a lab. Thank you for watching. Bye.